Welcome back to Geometry, Measurement, and Probability. In this video, we will be covering section 13.5 and talking about volume. So let's get started. To find volume, we count cubes, but to find surface area, we count squares. So let's find the volume and surface area of our two figures. To find the volume, I count cubes, and let's look at figure 1. So notice I have 1 cube in the front. Then on the next row, I'm going to count 2, 3. Then the next row, there are 2 cubes we can't see, so that'd be 4, 5, and then 6 we can see on the right side. Then we build up, so we have 7, 8, and last cube 9. And so we have a volume of 9. Now for surface area, we count faces that point out. So cube 1 has 5 faces that face the outside. Cube 2 has 3 faces that face the outside. So you have the top, the side, and the bottom. Cube 3 has 4 faces on the outside. The top, the front, the side, and the bottom. Cube 6 has 5 faces that face the outside, the top, the bottom, the side, the front, and the back. Cube 8 has 4 that face outside, the front, the top, the back, the side. And below cube 8, there's a cube that has 2 faces that face outside. It has a side and a bottom. Cube 7 has 3 faces on the outside. And below cube 7, there's a cube that also has 3 faces on the outside. The side, and the bottom. Then last, cube 9 has 5 faces on the outside. Add these black numbers together, and we get a total of 34, and so our surface area here is 34. Now, look at the second figure. Let's count our cubes. The first row has 1, then we keep counting in the next row, 2, 3. Then we have 4 and 5 on the right side, 6 in the middle on the back, 7, there's a cube below 7, so 8, and on the top 9. So we have a volume of 9. Notice that these two shapes have the same volume. They have the same number of cubes. The only difference is that the blue cube is moved to the right. But when we move that blue cube to the right, it changes our surface area. So let's count our faces on the outside. Cube 1 has 5 faces on the outside. Cube 2 has 3 faces on the outside, the top, the side, the bottom. Cube 3 has 4 faces on the outside, the top, the front, the side, the bottom. Cube 4 has 4 faces on the outside, the front, the bottom, the side, the back. Cube 5 has 5 faces on the outside. Cube 6 has 3 faces on the outside, the top, the back side, and the bottom. Cube 7 has 4 faces on the outside. The 4 faces are around the sides of cube 7. Cube 8 has 3 faces on the outside, the left side, the back side, and the bottom. And cube 9 has 5 faces on the outside. Add these numbers together, gives us a surface area of 36. To find the volume of a right rectangular prism, we multiply the length times the width times the height. So in example 1, we have a right rectangular prism. We multiply here length times width times height. So 5 feet times 1 feet times 6 feet gives us 30, and our units for volume are cubic. And so here we have cubic feet, because feet times feet times feet would be feet cubed, but we read that as cubic feet. Now let's look at example 2. Suppose an ice chest is 2 feet high, 1 foot deep, and 3 feet long. If ice costs $1.75 per cubic inch, how much will filling the ice chest cost? Well, first we need to find the volume of the ice chest. So our volume is our length times our width times our height. So we have 2 feet times 1 foot times 3 feet. This gives us a total of 6 cubic feet. Now, to make this problem more realistic, let's go ahead and change the cubic inch to cubic foot. So then to find the cost, we take $1.75 per cubic foot and multiply times 6 cubic feet. And that gives us a total of $10.50 to fill our ice chest. Next, we have the volumes of prisms and cylinders. The volume of any prism is given by V equals capital B times H, where capital B is the area of the base and H is the height of the prism. The volume of any circular cylinder is given by V equals pi r squared h, where r is the radius of the circle and h is the height of the cylinder. So let's find the volume in example 3. In part A, we have a prism. So our volume is the area of the base times the height. The area of our base here would be 3 times 10, and then the height is 15. Multiply this together, gives us 450 cubic centimeters. In part B, we have a right circular cylinder. Our volume is pi r squared h. Fill in 5 for r and 10 for h. 5 squared is 25 times 10 is 250. Our units for volume are cubic here, cubic centimeters. Then 250 times pi is approximately 785.398 cubic centimeters. Now look at part C. Again, we have a cylinder, and so our volume is pi r squared h. Our radius is 2 centimeters, and our height here is 3. 2 squared is 4, times 3 would be 12. Don't forget your pi. Our units are cubic centimeters. Type this into your calculator, and we get that our volume is approximately 37.699 cubic centimeters. When I compare a pyramid to a prism, I notice that the volume of the pyramid with the same base as the prism is 1/3 that of the volume of the prism. And so our volume of a pyramid is 1/3 capital B H. Again, B is the area of the base and H is the height of the pyramid. The same thing is true when I think about the volume of a right circular cone and a right circular cylinder that have the same height and the same base. The volume of the cone is 1/3 the volume of the cylinder. And so our formula for the volume of a cone is 1/3 pi r squared h. In example 4, we're asked to find the volume of each figure. Part A is a pyramid. So our volume of the pyramid is 1/3 capital B H. The area of the base, that's capital B, is 4 centimeters times 4 centimeters. Our height of our pyramid here is 5 centimeters. 4 times 4 times 5 is 80 over 3. And centimeters times centimeters times centimeters would be centimeters cubed. And we read this as 80/3 cubic centimeters. Look at part B. The volume of a cone is 1/3 pi r squared h. But notice here we're given the slant height rather than the height. So I use the Pythagorean theorem to find the height. The height is one of the legs, 6 is the other leg, and the hypotenuse, C, is 10. 36 is 6 squared, and 10 squared is 100. Subtract 36 from both sides, and we get 64 on the right side. Use the square root property, and we get that our height is 8. So plug in 6 for your radius and 8 for your height. Our units here are centimeters. 6 squared times 8 is 288. Then type this into your calculator. So you type pi times 288 divided by 3, and that gives us approximately 301.59 cubic centimeters. Look at part C. Again, we have a pyramid. So the volume of a pyramid is 1/3 area of the base times the height. The area of our base here is 4 feet times 4 feet. The height of this pyramid is 3 feet. The 3's cancel out, and 4 times 4 is 16, and our units here are cubic feet. Look at part D. The volume of a cone is 1/3 pi r squared h. Our radius here is 2 centimeters, and the height is 6 centimeters. 3 goes into 6 2 times. 2 squared is 4 times 2 would be 8, and our units here are cubic centimeters. We have centimeters squared times another centimeter gives us cubic centimeters. Type this into your calculator. 8 times pi is approximately 25.13. And again, our units here are cubic centimeters. Last, we have the volume of a sphere. The formula for the volume of a sphere is 4/3 pi r cubed, where r is the radius of that sphere. In example 5, we're asked to find the volume of a sphere whose radius is 6 centimeters. Here's our formula, 4/3 pi r cubed. Plug in 6 for r. 6 cubed is 216, and don't forget to cube your unit as well. Type this into your calculator. 4 times 216 divided by 3 is 288. Don't forget to bring down the pi and your units. And 288 times pi is approximately 904.78. Our units here are cubic centimeters. In example 6, we're asked to find the volume of a sphere whose radius is 8 inches. Our formula for volume of a sphere is 4/3 pi r cubed. Plug in 8 inches for that radius. 4 times 8 cubed is 2,048. And then type in 2,048 times pi divided by 3, and we get that our volume is approximately 2,144.66, and our units here are cubic inches. Suppose we have an ice cream cone. It's a right circular cone with a hemisphere on top. We know the diameter of the cone and the height of the cone, and we want to know how much ice cream will the cone hold. Our formulas for volume have radius. So first we need to find our radius. Our diameter is 60 millimeters. Divide both sides by 2, and we get that our radius is 30 millimeters. Then our volume here is half of a sphere, a hemisphere, and then plus a cone. The volume of a sphere is 4/3 pi r cubed, and the volume of a cone is 1/3 pi r squared h. Plug in your radius and your height. The radius here is 30 millimeters, and the height is 90 millimeters. To get the 18,000 pi, you would type 4 times 30 cubed divided by 2 divided by 3. That gives us the 18,000. Bring down the pi, and our units are cubic millimeters. Plus, to get 27,000 pi, you type in 30 squared times 90 divided by 3, and that's where the 27,000 comes from. Bring down the pi, and we have millimeters squared times millimeters. That gives us cubic millimeters. These are like terms, so add them together. It gives us 45,000 pi cubic millimeters. Type this into your calculator, and our volume is approximately 141,371.67 cubic millimeters. Suppose a tent is a rectangular prism of length 14 feet, width 6 feet, and height 6 feet. It's topped by a rectangular pyramid of the same width and length and a height of 3 feet. And we want to know the volume of the tent. So to find our volume, we find the volume of the prism and we add the volume of the pyramid to that. The volume of the prism is the area of the base times the height. The volume of the pyramid is 1/3 the area of the base times the height. Now notice I use different notation here because the heights are different for the prism and the pyramid, so I can't use just h for both of them. The volume of our prism here, we multiply the length times the width times the height, 14 feet times 6 feet times 6 feet, plus the area of the base of the pyramid is the length times the width, so 14 feet times 6 feet, and the height of the pyramid is 3 feet. 14 times 6 times 6 is 504. Feet times feet times feet is cubic feet. The 3's cancel out in the second term, and 14 times 6 is 84. Feet times feet times feet is cubic feet. Add these together, and we get 588 cubic feet. The last thing I want to show you in this section is some other conversion facts that you're going to see as you work on your homework problems.